Hey, this is Rory talking to you for the 2017 Autonomous Snowplow Competition. Beautiful St. Paul, Minnesota, Rice Park. We've got autonomous vehicles attempting to plow snow here. It's going to be a great event. We got schools from all over the country. So come with me. Let's talk to some racers.
Don't hit the sensor! I know what.
Autonomous Snowplow!
What's going to happen today? Who's going to win this thing? We're going to do Team Yeti.
We did really well last night. We did some testing in the middle of the night at school, and it went really well. So we have high hopes for today.
We're definitely going to show up. We're going to do some crowd pleasing. We're going to move some snow, and we're going to have a pretty good time.
I think we're going to do really good this year. I have a good feeling about it.
And I think this year we're really going to give everyone a run for their money.
So prepping the moving obstacle, which is a new element this year. Stopped. Excellent. Way to go, Team Yeti. All right, and we're done. 7 minutes and 17 seconds. Great job, Team Yeti.
All right, what'd you think of your run?
Better than expected, honestly. I think we plowed about 90% of the snow in total, and we didn't hit any obstacles, and we made it back to the garage, so I don't think we incurred any penalties.
What kind of technology did you use to see the stop sign?
It uses a laser rangefinder, also known as a LiDAR. It basically shoots out a lot of lasers and waits for them to bounce off of things and return, and the amount of time it takes for them to return is basically you can find the distance between that point.
So it's not color or anything like that. It could be any obstacle. It will
exactly. It just looks for obstacles that are roughly the size of the stop sign that's implemented as a moving obstacle, but it's actually kind of cool. It's about the same size as like a human, so if I walked by, it actually would detect me and stop for humans too. So, pretty cool.
Run by Case Western Reserve University. This is Team Auto XL.
Auto XL is about ready to hit the field. Yesterday it did pretty well, but had a little bit of trouble with the obstacles. We're trying to detect a stop sign, a parking meter post, and a tree. This is in a more of a driveway situation than yesterday's sidewalk. It's a lot more snow to plow, and the kids are going to do all right.
So they're now using ultra-wide band radio beacons to estimate their position. They have 4 beacons and with one more on the robot itself. There's 250 pounds of lead weight to give it traction.
What kind of navigation are you rocking there? Looks like we have some LiDAR and maybe optical.
What we start the navigation with is a Decawave ultra wideband system that functions as GPS but centered around the competition field here in St. Paul. And then we also use the LiDAR to detect obstacles, and we're also this year using cameras to detect a moving obstacle, which is new to the competition.
We actually had our moving obstacle detection actually worked too well because it thought I was an obstacle while we were out in the fields.
Our kind of official position has been it's not a matter of if, but it's a matter of when.
The real trend in taking the technologies that you'll see in this competition to the next level of autonomy needs to focus on perception technologies, on situational awareness processing, the architectures and algorithms that allow autonomous systems to make very complex decisions. For example, it's one thing that we can almost do fairly reliably today in detecting a human alongside the curbway as you're trying to automate the operation of a car. It's another thing to be able to predict if that human is going to step out in front of the car or not, and these are very subtle problems that are going to be a challenge to our image, scene, understanding technology.
So there's a lot of trend in the industry to go to multiple sensor fusion type situation. So you're taking cameras and IMUs and you're fusing that all together. And what we're seeing now, even in the students in the competition, what they're doing, going more towards image processing. You're seeing a lot of that with the Google and the Ubers and that type. You know, it's a hot technology right now. I think that's driving a lot of it. And also it's a technology that's being advanced the quickest. Like for example, using optical sensors. So how could they handle even a snowstorm, right? So if you can't see in a whiteout condition, how is a robot going to be able to see? It's not. So then how does that actually do its job? So you take that to the next level and you have obstacles, you know, like a dog or a person in front of you. How do you react to that? How do you keep it safe? So safety is definitely a top priority. And we're seeing that a lot with the Googles and the Ubers out there, is how are these things safe and how can they guarantee that they're going to be safe?
So here at Dunwoody, we really take on a practical, hands-on, learn-by-doing approach to education. And that's also what we try to do with our snowplows here. I mean, sure, we could have built in, you know, $100,000 sensors or LiDAR systems or GPS systems, only to discover that this may not work well in a real application. So we really tried to build a solid platform that we know works, and we tried to keep the navigation as simple as possible, not only so that our students could program it and work with it, but even so that a consumer, if they were going to purchase this at a Home Depot or a Lowe's, they could actually take it home and figure out how to set it up and make it work.
If you were going to commercialize this, what kind of price point are you guys at right now?
Roughly around $6,000, $5,000, $6,000. This project has always been about trying to get something that could eventually become maybe a consumer product.
If we use the same type of hardware we're using right now, it would cost about $1,200 to make one, so probably in the window of $2,000.
So, you know, we got to make sure we get that signal processing and navigation down, and we do that, I think it could really hit the shelves.
I'd say we're right around $1,000, $2,000, between $1,000 and $2,000.
I guess there are already commercial autonomous lawnmowers, and I think that if we were able to build on a platform like that, we could use some of the sensing technology and localization that we used here and some of the computer vision and apply it on a platform like that. And in a couple of years, I could see it plowing snow in people's driveways.
So the autonomous snowplow competition is a great way for these students to get involved in real-world engineering problems and kind of launch them into a career in the autonomous robotics community.
Honeywell looks at this as, you know, one point along the pathway in developing great scientists. Here you have college students who are starting to look at real-world problems using you know, state-of-the-art technology to get these robots to do what we want them to do. And if you look at the timeline, Honeywell is also involved in sponsoring Lego League for the smaller kids, and it's trying to promote the same general motivation in our youth to try to grow them to be the scientists that we need to automate the world in the future.
You know, I can see this becoming a commercial product in the foreseeable future.